Okay, good morning all of you. We are discussing about leophilic colloids are also calling as a leophilic source and leophobic source. Already yesterday given a definition as well as examples. Just these differences is asking for 5 marks in the board examination as well as in theory a competitive point of view is also important. You check in this math 2020 JMS he asked from this only one question, a theory question. You see that everything you will get it. What is the meaning of leophilic colloid? Is a colloid in which what will be the disposal phase is there, dispersion medium is there. I told very simply lick, loving. Loving means is a colloid or sol in which between disposal phase and dispersion medium what will be their mass? A very good strong force of attraction will be there. Yes sir. Okay, because of strong force of attraction, just I want to tell some other example. Anybody example for this one? I told so many examples, all natural source like starch soul, yes or no, and protein soul, and as well as gelatin soul. Yeah, we can take all these, and otherwise cellulose soul. These all are under comes leophilic source. And what is the meaning of leophobic? Phobia. Phobia means not loving. Not loving means hating. Means is a colloid in which between dispersal phase and dispersion medium may have low force of attraction, or some cases there is no force of attraction with the dispersion medium. Such colloids is calling as a leophobic colloids. Can you give us some example? Yesterday I told already all metal source. All metal source we can take like gold soul and silver soul like that. And I told some other very good sulfur source. Sulfur soul. Sulfur soul means sulfur means it is the acid molecule. Will come in p-group element. We have crown shaped is 8 sulfur atoms will be there, and like that I told some of the hydroxide salts like ALOH taken thrice sol, and as well as FeOH taken thrice sols. These all are leophobic salts. Comes to some special characteristics of this one. In case of leophilic, if dispersion medium is the water, then we are calling that sol with some special name. Yesterday I told already. If dispersion medium is a water, we are calling as hydrosol or aquasol. Okay, it is liquid, so we are calling as hydrophilic sol. In this case, if you are taking dispersion medium is a water, then how you will call this sol? Yes, very good. It is nothing but hydrophobic sol. Means in that sol between water and disposal phase particle interaction force will be less. Comes to some other things. If you take this one, it is the more stable. Leophilic sols are more stable. And sir, what is the meaning of stability? Okay, you take a disposal phase particle mixed with dispersion medium. Then what we are getting? Sol we are getting. That sol will be stable, I am telling, in case of leophilic. Why? Force of attraction will be more. But what is the meaning of stability? You take a disposal phase in dispersion medium. Observe very carefully among. These are which particles? Colloidal particles. And this is which one? Dispersion medium will be there. Yes, these are nothing but colloidal particles, are nothing but the disposal phase. And what is this one? Dispersion medium. Okay, what is the meaning of stability? Always colloidal particles want to interact with the dispersion medium. Means always colloidal particle will be mixed with the dispersion medium. Are you understanding? That character is calling as more stable. Why they are always want to stay with the dispersion medium? Yes, always disposal phase particle having strong attraction with the dispersion medium. Now you comes here, these are less stable or unstable. They are low stable or almost unstable. Why? It's very clear. If you take here dispersion, you take soul, in that colloidal particles is there and also dispersion medium is there. What they are doing, they don't want to mix with the dispersion medium. Why? Force of attraction will be less. Always what they are doing, they want to settle down. Always colloidal particle will be settled down and the dispersion medium will be like this. Separation will be happening, that is calling as unstable or less stable. Are you getting or no? And one more thing I want to tell, this preparation will be very easy. Preparation of lyophilic sols will be very easy. Very easy. How? By direct mixing of dispersed phase with dispersion medium. Yes or no? Can we tell one more example? Starch sol will be there. How you are preparing? Starch powder you can take that starch powder mix it with water. What we are getting? Sol we are getting. Are we using any special methods? No. Why? Yes, sir. This starch particle has more affection with water particle. Automatically, whenever you add starch powder in water, it will goes into the water and create or forms soap. But that is not happening in the lyeophobic. Means here preparation is not easy. Preparation of sols, this type of the sols is difficult or not easy. So how can you prepare? Okay, difficult means you are not living. You are trying to prepare them. This is possible by so many chemical methods. Some chemical methods we are using. Are you getting or no? Yes. And one more thing I am telling, these lyophilic sols are reversible in nature. Reversible in nature. Yes, what is the meaning of reversible in nature? Okay, first of all, you have a sol. Lyophilic sol will be there. In that what will be there? Colloidal particles will be there and as well as dispersion medium is there. You take starch powder only, starch sol only you take. You left some time. What happens? Yes sir, what happens? The colloidal particles will be settled down. Yes or no? Did you observe or no? Starch powder you mix it with water, you left 1 or 2 days. What happening? The starch particle will be settled down. Is it like that only? No, just again we can get it back. How? Yes, just by adding dispersion medium or just by adding water or just by stirring. What happening? It is undergoing changing its nature and again becoming a original state, that is calling as reversible in nature. The settling down like this colloidal particle concept is calling as coagulation. Yes, it's a huge concept we are discussing in further classes. That means settle down of colloidal particle like a precipitate in the sol is calling as coagulation. Indirectly nothing but precipitation happening. But if you can comes to lyeophobic, what happening? You have a colloidal particle will be there. Okay, you did some chemical methods and you got lyeophobic sol. Just within few seconds, what happening? They will be settled down. Like a which one? Precipitate. The colloidal particle will be settled down. That phenomena only we are calling as coagulation. Okay, by doing anything it will be come back? No, it never come back. Which whatever you do, again we can't get sol. Means it is the sol, and if you left some time, just very few, very less time if you can spend, it will becomes like coagulation or precipitation. Again it won't come back. That's why lyeophobic sols are irreversible. Irreversible. Are you getting or no? Yes. I want to discuss some other points regarding lyophilic sols. Lyophilic sols. Okay, and as well as we have to discuss lyeophobic sols also. Some other characteristics, lyeophobic sols. Okay, you see carefully lyophilic sols. We discussed so many. Still we have to discuss some other things. Here, dispersal phase are more solvated, or solvation is high or more solvated. What is the meaning of more solvated? Dispersal medium phase particles are more solvated, means the dispersal phase particles are having strong interaction with the dispersion medium. Due to this one, the dispersed phase or colloidal particle, is it visible or not visible? Yes, very good. Why? Because the dispersed phase particles is going into the dispersion medium. Is it possible to identify them? No. That's why the dispersed phase particles are not visible under ultra microscope. Ultra microscope. Are you getting or no? And we have to come. And one more point I have to tell. Here gives Tyndall effect or no. Generally we are telling colloids will give the Tyndall effect. But is it gives the Tyndall effect or no? No. Why? Yes, it's going into the solution. It's becoming like a dispersion medium. That's why what happening if you pass the or if you fall down the light rays on that one, there is no reflection. There is no reflection means there is no Tyndall effect. That's why we can tell no Tyndall effect here. No Tyndall effect. Still, I want to tell some other characteristics regarding this one. Surface tension. Sorry, before surface tension, you have to discuss viscosity. Viscosity of sol is more or less than dispersion medium. Tell me anybody. Viscosity of, yes, very good. Why? Because what is the meaning of viscosity? The force which resists the momentum of the liquid. You take a dispersion medium and sol, where attraction will be more in sol. Why? Because after mixing, what happening? Force of attraction is increasing. Whenever force of attraction is increasing, is it moved freely? No. Means some more force is resisting its flow. That's calling as viscosity. That's why viscosity of sol is more than dispersion medium. Yes, this one will be asked in that JEE mains examination. Why? Because of in sol more force of attraction will be there. Are you getting or no? And we have to discuss one more thing: surface tension. Surface tension. Surface tension is inversely proportional with viscosity. That means the surface tension of sol is less than, yes, less than a pure dispersion medium. Are you getting or no? Yes. Same characteristics we have to study in neophobic. Is anybody? Dispersed phase or colloidal particles are less solvated or low solvated, means they having less affection with the solvent, means with the dispersion medium, because already we know dispersed phase has less or no force of attraction with the dispersion medium. Then what happens? Yes, they can't go completely mixed with the dispersion medium. Then what happening? They are almost like a separation, but not completely separate, but separated. That's why it can be visible. These particles are visible under ultra microscope. Yes or no? See some other points. What is that one? You have to see Tyndall effect. Is it giving? Yes. Why? Because they are almost like a droplets. That's why they are giving a Tyndall effect. And can you see one more property? Viscosity. Viscosity will be any changes? Any changes after mixing? No. Why? Because after mixing also there is no much variation in the force of attraction. That's why viscosity of sol is same as, yes, very good, same as dispersion medium. Why? Because after mixing also there is no much variation in the force of attraction. Same thing we have to discuss surface tension. Surface tension of sol is also same as which one? Dispersion medium. Every characteristic is very important. You have to observe very carefully. Based on all things only further concept is interlinked. This way observe very carefully. All of you clear? Yes. Now we are discussing about one more important concept, types of sols. Types of sols or colloids based on nature of dispersed phase particles. Dispersed phase means what? Colloidal particles. Colloidal particles means what? Particles which are undergoing dissolving. Based on that one, again sols will be some categories. First classification based on physical state. Second classification based on force of attraction. Third classification based on type of the dissolving particle. We have made three categories. Under this here, first I am explaining multimolecular sols. Multimolecular molecular source. He asked from this in CET. He asked a question from this concept. Multi-molecular source or colloids. What is the meaning of this one? Just I will explain very clearly. You see carefully. First of all, I am taking one solution. I am taking now. Solution I am taking. In the solution, what will be there? Solute particles is there, and as well as what will be there? Solvent will be there. Yes or no? Okay. In this solution, this is the particle, dissolving particle, but the dissolving particle size is less than 1 nanometer. Is it calling as a colloid? No. Then what happening? Itself, they aggregate together. That solute particles are aggregate together, becoming like a colloidal particle. Means like this. Okay, in that what happening? These are size will be like 1 to 1000 nanometer. The size of these particles is 1 to 1000 nanometer. These are formed by combination of so many smallest particles. Such kind of source only we are calling as, yes, multi-molecular source. Did you got my point? This is calling as a source. So what is the meaning of multi-molecular source? First of all, we are taking a solution. In the solution, dissolving particle size is too small. Then what happening? Those smallest particles, some number will combine together, becoming like a big particle. There should be under colloidal particle range. Such kind of mixes we are calling as a source, especially calling as multi-molecular source. Can you tell the definition? Multi-molecular soul means is a soul in which colloidal particle is formed by aggregation of so many smaller atoms or a molecules. Once again, is a soul in which colloidal particles are formed by aggregation or combination of so many smaller atoms or a molecules. Such a source is calling as a multi-molecular source. For example, I will give some all metal source we can tell about. Metal source. Okay, in the metal source what happening? Metal atoms is there, you know, very smaller size. Such kind of so many metal atoms are aggregate together becoming like a colloidal particle. Anyway, colloidal particle is formed by combination of so many smaller atoms. That's what it is calling as. Yes, I will tell you one more thing. It is nothing but sulfur soul. Best example for molecular. Sulfur soul. In the sulfur soul, what is the constant particle? S8 is the element. Even though it is a very small, but it is not undercomes colloidal particle range. What they will do? Such kind of so many S8 particles are aggregate together, becoming like a colloidal particle. That's why sulfur soul is also calling as a multi-molecular soul. Yes, we asked this one. Sulfur soul undercomes multi-molecular, macromolecular or associated colloids. Multi-molecular because S8 is also even very small. That's why such kind of S8 units will be aggregate together, becoming like a colloidal particle. So colloidal particle is formed by combination of so many smaller molecules. That's which calling as multi-molecular source. Now I will explain one more thing. It is nothing but macromolecular source. Macromolecular source or colloids. In that name only answer is there. Is a soul in which disposed phase or colloidal particle or macromolecules. You know what is the meaning of macromolecules? Macro and micro. Micro means smallest. Macro means big molecule. Means macromolecule means is nothing but big molecules. Those big molecules size is like 1 nanometer to or 1 to 1000 nanometers. Okay, then those colloids is calling as macromolecular source. Means basically whatever macromolecules is there, those only acting as a colloidal particle. No need of aggregation. Whatever macromolecules is there, if themselves under size of colloidal particle, so source is calling as a macromolecular source. We can tell very easily. Is a source in which disposed phase particles or macromolecules, its size is undercomes colloidal particle size is calling as a macromolecular source. We have two types of the macromolecular source. Under this one, natural macromolecular source. Natural means what? Naturally happening. Anybody? It should be already molecule should be colloidal particle size, but should be coming from natural. Nothing but starch, soul. starch sole, cellulose sole, and protein soles. These all are under comes natural macromolecular soles. Why? Because in themselves protein is the big molecule. It is under comes colloidal particle size. And what is the synthetic or artificial? Artificial soles, artificial macromolecular soles means we are preparing like polythene sole and polystyrene sole. It will come in polymers concept and nylon sole. These all are also a big molecular colloidal particle that we are preparing. So we are calling as a artificial macromolecular soles. Now we are discussing the very nice concept of a third category. It is nothing but associated soles. Associated soles or colloids. Yes. Anybody? It's a different and very important concept. For example, you take a particular substance. Okay, na? That particular substance I am taking it at low concentration with suitable solvent. Then what happening? It's undergoing dissolving. Okay, now yes, I am taking like this. In that what will be there? The particles is dissolving like this, and also dispersion medium will be there or solvent will be there like this. Then it is having which behavior? Solution behavior. Okay, no, I am taking same substance at high concentration. What happening? Anybody? What happening? High concentration is what? In the same unit area, amount of the solute will be more. Automatically what happening? The solute particles are close together. Whenever they are close together, what happening? Aggregate together or combine together. Combine together means becoming like a little bit big sized particle. The big sized particles only we are calling as soles. Means whenever you take in same substance at high concentration, those small particles are aggregate together becoming like a colloidal particle. Then what happening means this is becoming like sole behavior. That sole only we are calling as associated soles or colloids. Whatever aggregations is forming here, those are specially calling with one name myceli. Myceli. I think you use this word in biology. Anyway, we will discuss briefly here. So means if you take any substance at a high concentration with a suitable solvent, then the solute particles is undergoing aggregation, is undergoes colloidal particle size. The aggregated particles only we are calling as myceles. Actually they are colloidal particles, but specially we are calling as a myceli. The whole material is calling as a sole. But this myceli or sole formation will be taking place at high concentration. That's why I am telling that myceli formation. Some important bits is coming here. Myceli formation takes place at above a temperature. Above a particular temperature is called Kraft temperature. Kraft temperature denoted by Tk, and this myceli formation takes place above a particular concentration. Above a particular concentration. This is calling as CMC. What is the meaning of this one? C, critical. M, myceli, critical myceli. C means concentration. Critical myceli concentration means what? The myceli formation in the soles will be happening above at a particular concentration. Below that it is behaving like a solution. Above that particular concentration it behaves like a sole because of formation of the myceli. That particular concentration only we are calling as CMC. Is important bit. What is the meaning of critical myceli concentration? Means the myceli formation will be happening above at a particular concentration of the solution is calling as CMC, critical myceli concentration. The whole things will be happening above at a particular temperature is calling as Kraft temperature. Are you getting it? Yes, these all things we can discuss here. We are discussing about the myceli formation. Myceli formation is a nice concept. You see carefully. Myceli formation we are discussing under soap solutions. Okay, do you know soap formula? Soap means it is nothing but sodium or potassium salt of fatty acids. Fatty acids. What is the meaning of fatty acids? Somehow long chain having carboxylic acids. Yes, whatever soap you can take, whether washing soap or clean is generally body soap, whatever you take, these all are nothing but sodium or potassium salt of fatty acid. Fatty acid is long chain having carboxylic acid. I am taking one of the carboxylic acid is stearic acid. Do you know the formula of stearic acid? No. You see, it is nothing but sodium or potassium salt of stearic acid I am taking. Stearic acid means it should be having a long chain and carboxylic acid. Generally formula C17H35COOH. Imagine once a 17 carbons having chain will be there. Its salt means what? Yes, what is the meaning? Here hydrogen will be there. Acidic hydrogen can be replaced with either sodium or potassium. For example, I am replacing with sodium. We have to take C17H35COONA. This is a soap formula. You are taking this soap in which one? Water you are taking. What happens? It is solid? No. It is decomposing like ions. How? It is shifting like this because metal non-metal comes here plus. C17 H35 COO minus plus Na. Na plus goes into water because ion dipole attractions. This is positive charge in water, oxygen has negative charge, automatically Na plus is pulled into the water. But it will not do. Why? Okay. Yes, very good. Here what will be there? No? This 17 carbon having chain will be there. No? Can be shown like this. 17 carbons having lengthy chain will be there. And also what will be here? C double bond O and O minus. It will not interact with water, but it will go is dissolving in water because ion dipole attraction. But here not happening or not going into the water. Why? Yes, sir. You have lengthy alkyl chain we have. That is nothing but alkyl chain. This alkyl chain is made up of only carbon and hydrogen. Between carbon and hydrogen, equal sharing or unequal sharing? Equal sharing is going on. Why? Carbon electronegativity 2.5, hydrogen electronegativity 2.1. Electronegativity difference between them will be very less, near to 0, means 0.4. That's why whatever shared pair is there between them going equally. Then carbon hydrogen atoms is not getting any charges. That's why alkyl chain means it is nothing but non-polar. That too like tail. That's why in stearate ion, whatever organic chain will be there, that is considered as non-polar tail. Comes to head. Yes, this part is there. This part having some polarity. Yes or no? Some charges there means polarity will be there. That's why it is calling as polar head. Means if you take any soap along with water, the soap particle has two parts. One is non-polar tail and polar head. This non-polar tail having water loving or water hating. Water hating. Why? Because non-polar and water is polar, never dissolve. You know solution like dissolves in like. So that's why it will hate the water. That's why non-polar tail is also calling as hydrophobic tail. It is nothing but hydrophobic part. But polar head, polar, water is polar. That's why polar mixed with each other. That's why polar head is acting or having which nature? Hydrophilic in nature. Hydrophilic part or hydrophilic head. Can we show this one as a shortcut way, like tail will be there and this is the head. Are you getting that now? Yes. Now I will explain this concept only. Soap solution. Soap solution, we are taking it at low concentration. What happens? Yes, he asked this bit in some competitive examination. If you take the soap solution at low concentration, in the soap solution what will be there? Hydrophobic part is there and hydrophilic part is there. Okay, now I am taking the soap solution in a water bowl. Okay, this is the water. What he asked a question in the concrete examination. From the soap solution, which part going into the water? Head or tail? Yes, very good.